1 second. Please give 1 second. One second, please give. Hello, can you able to hear me? Is it now fine? Hello,
Sir, it's fine, sir.
hello. Okay. Yeah, hi Mahesh. Is there any doubt for
Yeah,
your
hello.
side?
Yes, sir. No, sir. Like actually, I meant to do some layouts. After that, I will ask you.
Okay, 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 okay. Okay, let's start the class. Let me share the screen once and let me find that PPT. Let me open that PPT once. And yeah. So last time we did the XOR gate completely. We have completed the routing, DRC and LVS. So for today, I will be doing this will be the last lecture for these basic logic gates and implementation in cadence. From next class onwards, we will go for the module 2, which is our fabrication part. For today, I will be drawing this full adder circuit. I will do the full adder layout on the like what I can say in the cadence, so that you guys, whoever has not got the layout thing, will also get again able to understand. Okay, so let me, this circuit we will be drawing. Okay, let me go to the cadence once. Okay,
Sir,
yeah, tell.
sir, yesterday class is not uploaded, sir, in Drive.
Yeah, uploaded. You can check in the directory, please. I've messaged in
No,
the night. See, you can
no,
check
I checked,
once.
sir. Actually, I didn't get.
Like
Yesterday
yesterday
date,
class is
it's
not.
not showing.
Okay, 1 second. Give me 1 second.
Yeah,
Give
yeah.
me 1 second. Please check now. Please check now once. Is it visible to you guys or not? And confirm me. Please check and confirm me.
Yesterday, actually, October
No,
11th only
sir,
it's showing last. Yes.
it's not showing.
You should be getting 1 second. Like 19th, the 19th, please check they were getting the 19th number or not. 19th, please check. You should might be getting that one.
No, sir, it's not there. It's not showing, sir.
Not
It's not
showing.
showing, sir. Yeah, yes, yes. It's not showing.
Okay. Okay, let's finish the class. I will check and I will fix it. Why it is not showing. Okay.
Yeah, okay, sir. Yeah.
So let's start the class for the full adder. Okay, so we are in the tools and library manager. Okay. Lohita, can you open your mic and tell that what the issue you are facing so that we can help you now? I can help you now parallelly. Hello, Lohita.
Hi, Subhash.
Yeah,
Actually, my
yeah,
laptop
tell.
was not available now.
Okay,
I'm logged in my phone, and I'll connect after this class with you, Subhash, because I had
Okay,
basic doubts.
okay. Okay, so we were in the weekend one, and let me delete these guys. Inverter NVTST. We don't want. One second, please let me delete these guys. Uh, me delete it. Okay, test two. Actually, we need an inverter as well, right? We need an inverter also. Let me get one inverter also. Okay, we need an inverter. Let me take one inverter also. Mux, this is a logic gates in which we should be getting an inverter, right? Let me copy this guy, this logic gate guy, somewhere here. No, so not sorry. Let me copy this logic gate guy somewhere here and let me align it. Okay, then we will start. Mm, and digital gates, that should be fine now. Save. NOR and XOR gate inverter. This should be our fine. Okay, let me copy it. Copy to the weekend folder. Weekend. This should be fine now and okay. Overwrite all and okay. I think we need a OR gate as well. We need a OR gate as well. So we need a OR gate also. Oh, sorry, NOR one. Right. 1 second. Let me copy this one as well. So you guys do not need to do these things. I am just copying these files, the previous files what we have designed. I am just copying them actually. Okay, I'm just aligning them with my system because I have formatted things. So that's the reason I have to do this one again. So you do not need to do these things directly. Okay. Let me go and take this. It should we have the NAND inverter. 1 second, please.
Sir, your voice is not audible, sir.
Huh? Now is it audible? Hello.
Yes, sir. Yes, sir. Sir, now it's audible, sir.
Okay. That is actually some kind of I don't know. It's some kind of Teams issue, I think. Like I have changed the headphone also. Still, it's the sounds are not proper. Okay. So what I was doing actually, I was supposing to take a NOR gate, right? Okay. NOR one. Okay. I should in the NOR gate, the mux one. Let me take copy this guy and put in the view at home. Should be fine. Yes, now that should be fine. 1 second. Desktop mux is the mux we need and save here. Okay, where's the mux man? Yeah, here. NOR one and inverter should be here. So this inverter is also the same one what we are using. Okay, mux. This is the NOR gate. You also need the NOR gate one also NOR one. Copy. Let me copy it to the weekend. Okay, we are now ready to start of the full adder actually. Okay, let me go to the cell view. Let me rename it as a full adder. Okay, okay. So let me explain this one again. So this is our CWI window. Whoever has not learned, this is our CWI window. Here we will go to tools first. We'll go to library manager. Okay, in the library manager we will get getting library. Create a library first. We'll go to the files. We'll go to create new. We can create our library. You can create any library from here actually. We can create any library from here. For now, I'm not creating any library. Already our library name as weekend is created. Our library is already created. We will just select it. We'll go to files. We'll go to new. Only we'll make a cell view actually. In cell view, we will be naming it as a full adder. Score ADD full adder actually. Okay, and we'll press OK here. Means actually we are trying to create the schematic actually. Okay, we're trying to create the schematic. We'll press this one. We'll browse here. We'll go to weekend, and our device require two XOR gate, two AND gate, and one OR gate. Okay, so two XOR gate we will be taking first. One and two. Okay, one and two, we will be taking it like this. So like this, we will taking it. Okay. And then we will be taking, then we will be taking NAND gate again. So NAND gate, why you are taking? We are taking NAND gate to make it AND gate actually. Okay. We are taking NAND gate to make this AND gate actually. So we don't have a AND gate separately. We will taking this to make the AND gate actually. Okay. Then we will be doing one thing. We will be taking a NOR gate also. NOR gate, we will creating a OR gate using this NOR gate. So to create them, we will be using inverters. So we will be using like one inverter here, one inverter here, and one inverter here. Okay, let me put it somewhere here, and let me take this guy up till here. Okay, is it now clear to you guys why I have done this one like this? They have AND gate, and OR gate. Okay, but we haven't created any AND gate or OR gate. We are creating this AND gate and OR gate using the inverter. We are converting the NAND gate and NOR gate to AND gate and OR gate using the inverter. Is it correct? Is it okay for you guys to understand what is the hierarchy going on in the background? Hello, hello.
Yes, sir.
Yes, sir.
Is it okay? Okay, so now we will be able to go to that part and we will try to connect them. Okay. So for the connection, what we will be doing, we will first try connecting these guys. Okay. Wait, let me do it in this fashion. Okay. A, like B and a C. Okay. Then what we will do, we will be, sorry for my throat. We will be taking these connections from here as well. We will be taking these connections also from here. Okay, let me do it properly. We'll be taking the connections from here also. And we will be putting one connection here and one connection I will be putting somewhere from here. Okay. Okay. Then what I will be doing, I will be connecting both of them. Again, what I will be doing, I will be going from this part. Okay. From the left part, I will be going. Okay. So from the top, I will be taking this like this. Okay. Is it going correct only? Okay. I think something wrong is there. I think that 1 second. It should be like this, not like that. The connection should be like this actually. Let me connect it like this. One should be like this and this should be like this. Okay. Now the connection should be okay. Now this connection should be okay. Now coming from here,
Sir, it will not start, sir, if we take on the wire.
what happened?
It will not short, sir, if we take a wire on wire.
No, it will not short. Now, if there is a circle like this one, if these circles are coming, means this point is connected. If there is a no circle, means it's not getting shorted. Okay. If circle, see here a circle is there, that is a joint actually, or the junction you can say. So if it is here like this, then it will be connected. Otherwise, it is not connected. So here it will like this. Then we will connect this guy also, and this guy also, and again we will able to short them like this. And we will connect it. Okay, like this we can do the full adder circuit, and now we have to connect these guys. Okay, we have to connect this VDD and VSS actually from the top to bottom. Okay,
Sir,
let me, yeah, tell.
sir, instead of taking this NAND gate an inverter, we can directly take the symbol of AND. Sir.
So how we will get AND gate? We never built AND gate. So for a symbol of AND gate, so we have to build a AND gate first, na? Then you will get a symbol. So we don't have AND gate actually. So that's the reason we are putting NAND gate and then we're putting an inverter, right? You got the concept? Hello?
Yes, sir. Yes, sir. From instance, we cannot take, sir. It is not possible to take.
Can you repeat again?
From instance, we cannot extract, sir. And get.
No, you have to build a AND gate actually. You have to go there and you have to build a AND gate separately. You have to, you copy the instance also. That's not a big issue. You can copy the instance also, but still you have to build the AND gate by routing it inside that one. So we will be building a AND gate only here also. The same thing we are doing here. Nothing else. So nothing else we are doing. We are also creating AND gate only here. Let me copy these guys immediately. Okay. Let me. Schematic wise, I am not very big proficient. Might be some other concepts are also there for the schematic, not a big thing. Okay.
Hello.
Yeah, hello. Who's this?
Sir, Srikant, sir. Yeah.
Yeah,
Sir,
tell.
So after the NAND gates, you are putting the one inverter. It will become the AND gate, right?
Yes, yes, yes,
So
yes.
after that,
Because in
after that, you're giving again one NAND gate, right?
no, that's a NOR gate because the OR gate is
S-
required in the full adder circuit. Now, if you see this one,
This is
see a OR
NOR
gate
gate,
is
right?
required.
Or
This is
this
NOR
is OR
gate.
gate.
No, this is a OR gate. We are creating a OR gate here by using
Okay,
NOR
okay.
gate and inverter.
Yeah, okay, got it. I thought this is AND gate, NAND gate. I thought, okay, okay, correct only. Yes, yes. Okay, sir, proceeds.
Yes. Let me connect these guys. Okay, and then we should be able to go below and let me connect these guys from here to here. Okay, this should be also be connected like this. Okay, up till here. Then I will be shorting both these guys. And okay, for here also I can short it with this one. And this one also I can short it somewhere here because it's going to ground only. Okay. And for this one, what I will do here is I will just put one, sorry, I will just put one connection from here actually. I will put that devices here only, not a big issue. I will make VDD as a, I'll make a VDD, then VSS. Okay. Then we will come here and we'll make what are the inputs A, B, and C in A, B, and C in C, I, and C in actually. This should be coming back here. We will be putting two outputs S and C out. S and C out should be uh, S and should be output, and we'll put here the output, and this should be a C out. Okay, this should be a C out. COUT out. Okay, this should be our full adder circuit. It should be passing the this warning thing. So where the warning is coming, we need to check that one once. So somewhere I think some warnings are coming. Let me check these warnings where this should be coming. Might be some checks we are unable to pass. I think it is coming somewhere from this part, right? I think it is coming from this NOR gate itself only. Because earlier this NOR gate having that issue actually of the extraction issue. Okay, I think where this, can you guys see the error? With the error coming actually, and two warnings found. What is running in the virtuoso? Let me find it somewhere here if I can get that error. Okay, let it be. We will see this later, this error thing. Okay, we can go into our launch. Okay, after the schematic is built properly, see after this after the schematic is built properly, all you guys can hear me? Is I audible? Hello?
Yes. Yes,
Yes, sir,
Subhash.
you are audible, sir.
Okay, okay. So after this schematic is built properly and we are now ready for our layout part, we will go to launch. We will go to layout Excel simply and go to create new and automatic we will do here and we'll press OK. Then we will directly go to this part. This layout part actually we will go directly So this is our layout editor window. Okay. Here I will press E option and then I will make 0.05 and then I will make it a 0.05 simply. Just our normal practice and we'll press OK. Now we are ready to generate the layouts. To do the layout, we will simply go to all from source, this option, left side below green option, generate all from source, this one. We'll click this one. We'll go to IO pins and we will select all of these ports. These are the input output ports actually of the full adder, C in, C out, S, A, B, VDD, VSS. And we will convert them simply to metal one pin, and we will update it immediately. So everything got updated here. We'll create as level and we will just go to options and we'll make it Roman and we'll make it 0. We can fix it here also. We can fix this one later also. Okay. Same as pin, same as pin. Okay. We'll do this one and press OK here. And these things are already updated and everything done. And now we'll press the OK. If we press the OK, we'll see these whole blocks are the pre-built blocks. What we have done earlier has already been generated. If you see, these pre-built blocks already got generated. The two XOR gates, two AND gates, two inverters, one a NOR gate and one inverter. So all things have got generated immediately here. Now we can use these things to make our design. To make the design, what we will do, we will see first these two devices are cascaded. Back-to-back connections are there at some part. Okay, but here one output is going out. Okay, so to do that one, we can put the, let me fix this both the things side by side. It will be easy for you guys to understand. Okay, let me fix this one side by side somewhere here. Okay, and then let me put this one a bit back. Let me enlarge this window. Sorry. Okay. Let me enlarge it completely. Remove this Y. Okay. Now, if you see here, by coming to this part, you will see the XOR gates. Two XOR gates are there. Okay. Side by side connection we can do. So first what we will do, we will take one XOR gate and we will drag it to the top. Okay. We can have two options. Either we can put this XOR gate below also at this level. We can also put this one at this level. And then we can get the input. Suppose the inputs are here, two inputs. The two inputs are highlighting at this level. Okay. These two levels are highlighting A and B. We can either put this guys here also, and the one output of this guy, that this output actually, this output can come and again it will come in, but it will be a big, very big long routing. That the reason we will put this device somewhere here. Actually, it will be easy for us. So the inputs are actually here. If you guys see, the inputs are here of this one. Then the output of this XOR gate is going to this one. So we can connect them easily from this point to this point. Then the
Sir,
input
you
was
can flip and keep the down also, right?
Yeah, can you repeat again?
You can flip and keep the downside also, right?
Yeah, we can see already I have done that one to see what will happen. See, the two input is fine for this one. Okay, the input of this guy is also fine. We'll go the output. Okay, but the problem will happen for this one. See, this is getting long. That is the issue actually happening here.
Oh no,
So
if you flip that one, it won't
Sure,
happen,
you
right?
need to rotate to right side. Rotate to
So
right
you
side.
want this guy to flip it, right? Like this.
Yes.
Then the input will hamper, na? See, this input will get hampered. Either we can pull this M4 routing to this part, that also we can do. See, already this track is in M4 actually. If you see this track is in M4, that we can do. That we can do. We can pull this M4 back. Okay, that we can do. That's not a big issue. We can do. So for that one, we have to flip this one actually. We have to flip this device as like this because the VSS and VSS should align properly. This VSS and VSS should align. We have to flip it like this then. We have to flip it like this. Then this VSS and VSS should align. Then we can overlap each other. Like this, we can overlap each other like this. Then it should be okay. Then it should be okay. Okay. Good. Thank you for this one. Okay. So the input should be straight here, this input, and this input we can pull this M4 metal from here and directly we can join it here. But the one thing what I am thinking was output. See, the output will hamper actually. Output should come at this side. It should not go in the left side actually. Then again that problem will be there. We have to pull the output from here actually. That problem we will be facing only. For a one input, we have to struggle for 2 to 3 things. Then we can put the devices somewhere. Then other devices need to come at the below stages. So we have to put these devices, these other devices at somewhere in the below. Okay. Then only we can route them properly. Otherwise, the routing will be get difficult. Otherwise, the routing will get difficult at this level. So for that one, okay, we can do it in this way also. The output will go at this level actually. Uh, 1 second. Let me flip this one in the opposite side once and let's check now the input status. What the input it is giving actually. Let me check once. Okay, now let me check the input is fine for this one. For this one also input is fine. For this one the output. Okay. So what we can do here is we can, okay, this output is creating the issue. This B is okay, fine, but this output will create the issue. It should go to the input actually. It should go to this input actually here. Actually, what I am thinking is the routing will be bigger in this case actually. Let's check the test case of that one also, that guy also. So if we put it in this stage like this way also, let's check the input and output thing. 2 inputs here. One input can be at this level somewhere. Okay, so somewhere at this level it should be. Okay, this level it should be. For this also the routing will become bigger. Okay, let's go with that one only. Better with go that way. In this also the output will become bigger. We cannot consider that input should that to create one output. So both the things will get hamper here. Better we will do with a higher metal. Not an issue. We can do that routing with a higher metal. We can put it here and then we can align it and we will put it somewhere here. Okay. Now let me consider this one. This one fine. This should be coming. Okay, for here A option. What about, let me check the connectivity nets once. What the connectivity net says, what the connection is coming. Let me turn off this via and poly layer. This should be fine. And let me click on this one. Okay, so it is connecting up till this level only. So we have to do one thing. We can pull one M3 metal from here and we can draw it up till this level. We can draw it with the M4, we can draw it somewhere. Okay, that can be done. That can be done easily. Okay, after this is done, we can go for the, sorry, we can go for these guys. Okay, these guys we can go. 1 second. We can go for these guys. Okay, so these two. Let me first combine both of them once. I think size wise both are not same, if I'm not wrong actually. I think size wise both are not same. Okay, okay. 1 second, please. Let me check that one once. I think I took the wrong inverter. Let me check this one. Go to design, marks. Okay. Logic gates, digital gates, nothing else. Okay, then let me go to the mux ones. So here, mux one. Okay. NOR one was there and inverter was there. Okay. I think I took the wrong. No, NOR one is the same NOR one we took. And the inverter, I think we took the wrong one, if I am not wrong. Let me take this mux inverter, then it will be okay. INV1. This inverter, let me take this inverter. Okay. Let me delete this inverter and let me take it. I think I took the wrong inverter. That's not matching the size actually. Okay, let me copy it and put it in the weekend directory completely, and okay, it should be now overwrite all and all. Okay. Now let me go to the full adder schematic and let me replace them. Now, okay, let me replace it. It should be INV, that should be fine. Okay. Let me go to the layout and let me delete these inverters once and let me regenerate them again. Okay. Let me regenerate, sorry. Let me go here and regenerate them again. Okay. Why it is not coming here? Why it is not coming? It should come now. Okay, let me do one thing. 1 second. Let me replace them actually. I think we need to replace these guys. Let me delete them and delete it and delete it. Okay, and let me regenerate this thing. Okay, inverter and should be okay now. One, two, and three. Okay, now it should be fine. Okay, let me now go here and take this guy again. Okay. Okay, now it is fine coming properly. Okay, these two will go for this one and this one will come for this one. Okay, and let me align them. And let me first align them properly with this one. Actually, I did this one to check the sizes actually. Actually, it was not earlier matching the size height actually. The height was different. Here, let me check it is matching the height or not. Otherwise, we have to do some modifications. Here also it is not matching actually. It is actually not matching the height actually. If I very frankly say, it is not actually matching the height. If I change the height from here, it will hamper this guy. So for that one, what I can do here is let me do one thing. Let me change this NAND gate thing actually. Let me change this NAND gate thing. Marks NAND gate. Okay, let me take this NAND gate. Rather taking, let me take this NAND gate only. Okay, let me take this NAND gate and 1 second, please. Okay, here the NAND gate is already there. Okay, let me do one thing. Okay. So don't, okay, so you guys can, uh, I am using this one different because of the size issue. It was our earlier pre-built. We haven't pre-built the NOR gate and inverter for this one. That's the reason actually it is happening here. NAND gate here actually. It should come. Okay. Now let me come up till this part. What's happening here? This one. Okay. Let me put it somewhere here. Then one guy should I put it here? Okay, and okay, this should be fine. The connection is leaving. Let me connect it properly with them. Okay, let me just connect these guys. Okay, this should be now okay. Okay, and now coming below here, we can. What's happening? This one, like this, we can join it properly up till this level, and I will connect back here. This one and this one, I will connect here. Okay. I'll press F and I will save it. Okay, now I will go to the full adder once again and I will delete these two NAND gates actually. I will delete them and I will go to select from source and I will regenerate these NAND gates again. Okay, I will regenerate them. This should be actually of this height only. This guy should be of the same height of this one. Hopefully now. Yes, same height. That should be fine now. We can go with this one. Okay, we can go with this guy. Okay, we can go with this block actually. Okay, so now we are just doing the normal stages actually. We are just trying to create them. So now if I consider this one, okay, now let me first align them properly. I'm just aligning them with this respect to do this one. What I can do here is, one second, please. I'm just connecting it to PR boundary to PR boundary. We will be drawing these layers later. We will draw this layer later actually. So for this one, what is the issue will happen? The output is getting connected to the input actually. It is built in such a way that output automatically gets connected to the input actually here. If you see here. Okay, and for this case also, I will be taking this one and I will taking this inverter and I will be aligning them properly so that I can take them and put it in the top level. Okay. Same thing will happen here. It will get connected here. For this one also, it will get connected immediately. The output will get connected to the inputs. Okay. If you need any modification, you have to change it according to your system, routing system. Okay. So just use this one. Okay, we need this inverter guys to get connected here. Okay, so the connections here are like the two inputs are coming from the top actually. Okay, this see two inputs are coming from the top. One actually coming from this output, so which will be get connected with a long routing with this level and one with the this level. So we can draw two M3 metals to short them actually to connect these two guys. So we can put these things here only. So already the VDD connection is there, so we do not need to touch anything. We just need to uh, align them as per the requirement and we'll just put it somewhere here. We'll just put it somewhere here actually, these guys, and we will align them as per the requirement. Let me align them properly. Let me align them. Okay, and they are not coming over this. They will give DRCs actually. Actually, they will give DRC. We will see the DRC later. Okay, because this it is overlapping here. Na? This will give this tap will give the DRC later. We will see that one. Again, we will copy this one and we will try this guy to up till here at this level. And we will see here how this connection is coming. Let me check this one. How connection this is coming. This is coming from this top level. This one and then this one. Okay, it is somewhere coming from this level. This also we can short with M3 metals. If I'm not wrong, we can short this one with a M3 metal completely. Okay, we can short them using a M3 metal. Now, what I will do, I will just simply align them to this level. Okay, and this one, I will simply align these PR boundaries to PR boundaries at this level. It will automatically, everything will get connected for me. Okay, everything will get connected for me at this level. Okay, but the problem here will be, the problem here will occur here at this level actually. Okay, one second. Okay, at this level, the problem will be there. Means we cannot short them directly. If we short them, then these connections will come. So we have to find some other place actually. So other place should be some other place should be there. Okay, so that we can put, because this tap is coming at this level. So because this tap is this sorry this metal is coming at this level, we cannot route it here as it is. Directly we cannot route it here. Okay, so for this one, what we can do here is, if I align them, both of them now. Okay, let me click OK and align this guy to here, and then this guy to at this level. See, it is getting shorted. For that one, what we can do here is we can change this thing inside. Okay, we can change this. We can just delete this M2 routing. We do not need this M2. If we don't need, we can delete it. We will do the M2 routing in some other way actually. We can delete the M2 routing in some other way actually. Okay, but here we will get shorted. That is the problem here actually. With the VIA, actually it will get shorted here. The problem is that only. So okay, so let me go out of this one. So either we can just take these two guy and we can separate them so that we can get some space. Like what I can do here is I can make a gap of 0.2 micrometer and I will be placing these devices because they need that much level of distance only from M2 to M2. Sorry, it should be from M2 to M2. Okay, they need that one level. So we will draw a boundary at this level. We can draw a boundary. Actually, if you go with a standard cell placement, this error will not come. We are not doing this one with a standard cell
ఇప్పుడు
placement. That
ఏమేం
is the
కావాలంటే
reason.
అది డిష్ వాష్ తీసుకురండి తీసుకొచ్చాక చెప్తాను ఇంకా ఏం కావాలో అన్నాడు.
Hello, who's this? Please turn
ఉందండి
off the mic.
కనెక్షన్ చూసుకోండి.
Hi, Mahesh.
మండి
You're telling something? Hi, Mahesh, you're telling something?
నో సార్ నో.
Okay. Okay, actually, we need either we need to change this routing inside this inverter. We have to change this internal routing of this inverter or of this output, or we can just make a separate here when we will draw and we can draw this line. So let me think of this one, how we can proceed with this guy. How we can proceed it, we have to think it. Either we change it. I think changing will only be the good solution here. We can, but the thing will be, but only the thing will be creating a issue here actually. Okay, let me do one thing. Mhm. Okay, let me do one thing. Let me do one thing. Let me stretch them back. Let me go inside this guy. Let me turn on the layers. Okay, Shift F. And then what I can do here is I can just simply stretch this guy up till this level. Okay. I can just simply stretch them back up till this level, a bit of this level, I can stretch them. So what will happen? They will be getting a good amount of space here, and I will stretch this one back up till this level. I'm not putting it up till here. I'm just putting this guy a little bit of stretch I have given so that I can use this, what I can say, I can use this. I need a bit of stretch this side also. I need a stretch a bit of this side also. Both sides should be actually same as of the connection. It should be point, I think point 2 should be fine from here. If I'm not wrong, I think point 2 we can do. Point 2 is needed. Okay, point 2 micrometer is only needed up till this level. Okay. I think point 2 micrometer is only needed at this level. Let me do one thing. Let me stretch them back up till here. Okay, 1 second. I think point 2. Where is point 2? Up till here. Okay, we can just pull them back up till this level. And this one I will, okay, up till here done. And we can pull it back. I'll just pull this one back up till here. So the distance between now them will be zero point 0.2 micrometers up till here. And from this side also, I will be doing the same thing that put 0.29 micrometer only. Okay. Same thing that zero point 0.2 micrometer only I will do. Okay. So what is the spacing between these two? Giving 0.25 from this side. So 0.25 only from this side we will do 0.25. Okay, let me do it like this. Let me do it up till here. Okay, now this should be fine. Okay, now this should work. Now this should work actually. Okay, if I'm not wrong, this should now work. Now I can align them. Now if I align them, I will get the connected layers also. We will connect these layers manually. And here also, if I now connect them actually, if I now connect them actually up till this level also, like let me align this, sorry, these two guys actually. Okay, now if I take them and try aligning at this level, I will able to see a distance above 0.2 microns, which will not give me any DRCs. To connect them, we can use metal 3 from here. We can draw a metal 3 from here. We will able to connect it. Okay. So we can arrange these connections like this. And now coming to the final part, which is our this device. Okay, let me pull it. Let me align this also. Okay, let me take this guy and let me take it somewhere here. It says that the output should be from these two inverters. Actually, the outputs are coming for to this device actually. Okay, so the from the output is coming from from these two device. Okay, one from here and one from this guy. Okay, so for that one, what we can do here is, okay, okay, 1, 2, 3, and a 4. Okay, okay, okay. We can do that one also. Either we place these devices below. Either we place these devices below. Either we can place it somewhere here. Let like we are trying this one. Okay, we are making it, we like this is a part of a floor plan. So what is floor planning I will tell later, but these things need to be do at this level only. So if I think this connection is something different, these two connection, so sorry, These two connections should come. One should be from here, and the one output will go from this level. This thing I can draw a M3 metal from this level, and I can just connect it. I can simply connect these two things, okay? And for this one also, it should be going to this part, okay? And for this one also, what I can do here is I can go and align it this one with here. Okay, I don't need it like this. Okay, I don't need these guys like this. Okay, the problem here will be of this one only. If I pull this guy up till here and then I start aligning with this respect like this now. Okay, now I start aligning this one with respect to this one. The issue will be, let me flip this one also. Let me flip it. Align this one with this one. Let me align both. Now, if I try to put these two devices somewhere here, can see this there is a routing issue will come here actually. If I see, I think these two are okay now. Okay, now what I can do here is VSS are there connected properly. Okay, then one thing we can do in this one, we can pull this guy back a little bit. We can pull this guy up back a little bit. So we are just modifying it as per some of the requirements. When it is required, we can just bit of modification can be done. I think some track is coming out of this one, right? Let me press E and make it 0.05 and then 0.05. Okay. And then I can just align this one with this one. This should be now fine. Okay, now this one I can pull it back a little bit, which will help me out to route this one. Okay, will help me out to route this guy. Okay, let me, I'm just pulling this one back. Wherever required, I will just use it. And sorry, B, and I can come out of this one. Okay, now if you see, the distance will be quite enough to route. Okay, we can route it now properly. We can route it now. So they are also fine from this side, both are fine. Alignment is also proper. Now what we can do here is we can take this guy up till this level and I can connect them. I can connect this one guy up till here and this up till here. Okay. So this output, two outputs from here can come at this level actually. Okay, so if you see, two outputs can come from this inverter. So from this inverter, one output will go at this level. We can draw using a metal 3 and or a metal 4 to connect them, and one output can come from this level, and then we can pull this guy up till here and we can simply short them at this level. Okay, so this is okay. Sorry, I think they are not aligned as per the requirement. They should be aligned as per the requirement actually. They should be aligned. They are not aligned actually. Let me align them. Okay. Okay. Now, if you see, these guys are properly aligned. These devices are properly aligned, so we can use them actually. So we can just simply draw that this PR boundary from here to at this level. At this level, we can just simply align them. And this guy, we can simply align them up till here. And for this side, we can come and we can align it up till this level. So if you see, this is the complete, sorry, from the top. As from the top, I can just simply align this one and come back up till below. So if you just see this one, so this is the whole complete routing stage of the this device actually. If you see here, okay, now we can start the routings. Now we can start the routing here. Okay, Is there any queries related to this one? Might be some difficulties you might face. Is there any difficulties you can ask me now? So why this has been done, why that has been done, you can ask me. Hello, everyone.
Sir,
Yeah, tell Arshad. You can tell Arshad.
sir, instead of that, thing that NAND gate and NOT gate for, we can directly do the AND gate and OR gate now, sir. It makes the routing easier. It's looking
How
somewhat
how we
routing.
will how we will get and get, you can tell me.
NAND place not gate is called AND gate only.
That also I know, but in CMOS, tell me how you will building a AND gate. Is it by default can we make AND gate? Can by default tell me can we build a AND gate? Arshad, you you have already passed the engineering and you are capable of answering this question. That uh, can we by default make a AND gate and OR gate in a CMOS or a PMOS or NMOS, whatever? So we are working in CMOS. I'm asking for a CMOS only. Can we draw it like this? Okay, Mahesh, you can press G. It will come. Okay, Mahesh, I will check this one. Hello, Arshad.
Sir,
Yeah, AND gate and OR gate cannot be built by default. NAND gate, NOR gate, and NOT gate can only be done. AND gate and OR gate you have to build using NAND gate and NOR gate only. By default, you cannot make it.
sir.
In CMOS, first you can make only default those things. Thanks, Mahesh, for this. This I was also not knowing in the schematic because I am not a schematic engineer. I am not friendly with the schematics actually. This G option, instance I4 floating input. Where is the I4 and I10? In and out, in and out, in and out. Where is the in and out, man? I think I4. This is I4, right? In and out. Why this is coming? Okay, let me turn on this. Where is that guy? Full adder. Let me turn on the full adder once. Okay, so that G option was coming on the I4. Actually, the I4 is this guy, NOR guy. I think there it is giving option as out on instance I4 out. Where is the out, man? Out. It is floating somewhere. Okay, it is somewhere floating actually. New window. If we see this one, the out in this one is floating somewhere. It says that this is floating. Okay. Might be floating. Okay. Let me do one thing. Let me put this one out. OUT out. This should be like this now. But still it is coming. Why? Warning terminal out in view schematic is output, but is input in NOR 1 symbol. Input in NOR 1 symbol. Okay, I think some mismatch is there with the symbol and this is schematic actually. NOR 1. Okay. Let me do one thing. Let me go to this one. Oh, sorry. I will look at virtuoso and NOR 1 symbol here. It's out only. I think I will check this mismatch. We don't have time to check these things now. I think it's not driving the schematic actually. Let me save and relaunch this one. It should come fine now. Okay. This is schematic. Okay, now go to full adder, layout, open with layout Excel. I want layout Excel actually here. Okay. And I'll press OK. It will turn on everything for me. And okay. AND gate and OR gate I cannot use directly here. It will not, it's not feasible. So we have to build it. Still, we have to build that one. Na? So NAND and NOR, we have to make a separate library. We have to make AND and OR gate. Then we have to build it again and again. So directly we can use the things here only. Okay. So that is the reason I directly used it here. Okay. So is there any question you can guys ask me so that I can start the routing things? Hello. 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 Let me put this guy here and this one also at this level. Okay, so that I can get this layer palette properly. Okay, let me enlarge this window and put it somewhere here. Hello, is I am audible?
Yes, sir.
Okay. Well, let me put them somewhere here. This also somewhere here. Okay. Okay, now this should be fine. I'm just using this two. And this should be now come below. Now I can start the routing part. Okay, I can start the routing part now. Okay. So coming to the A input A here. So this should be connecting with this guy. To connect them first, I have to check, I have to use metal 3 layers to connect this M2. Okay. So what I will do, I will just only turn on metal 3 and metal 2 only. Nothing else I will turn on. And for to highlight this A connection, I will go to this navigator. So how to get the navigator? Let me tell you. Go to this part, right click, select navigator will come. It will help you to route everything. Okay, I have just turned on the M2 and M3 because my target is to connect these two M2 connection. Either I can use M1, but I cannot use M1 because this is a long routing. This will be a long routing of roughly of 9 microns. M1 is not advisable to route with 9 micron. So we will be using only M3 here. To connect the M3, I have to turn on the M2 and M3 layers because some M3 smalls are also there. We have to find those areas where M3 are there and we will not route those parts. We will just simply bring those guys up till from here. So already you can see M3 is at this level. I can simply draw this M3 directly and I can short it, but this guy is waiting for us on our way to stop us. So for that, the reason what I will be doing, I will just draw M3 from here only. Okay. I will simply draw a M3 from this level. Okay, from this level, I will be drawing M3 connection, M3 metal up till this level. Okay, I can draw a M3 metal from this level. And what does it tells us? That there is no routing space available here. We can simply draw the metal 1 and metal 2. We can do one thing. We can we can take this guy. We can make it 0.26. We are using the width. We're using 0.26 width. We can just simply pull them up till here with a distance of 0.2 micrometer. 0.2 micrometer is required here. Okay, you have to put this much of spacing between M3, M2 and M1. Okay, so you should be maintaining that every time. So here also 0.2 is coming. Okay, then again what I will do, I will be just drawing this M2 metal from this point to this point simply. See, I haven't probed it, sorry, highlight it. So okay, so M2 will come from this level. Simply it will come and it will get joining here. It will join here and I will just simply make it 0.26 micrometer. Okay, it is joining this level also. Here again, I will drawing on one M2 metal here also. So that because this metal is already there. But why this is highlighting? It is highlighting because that M2 metal is at below level. For this level, you have to draw a metal on. See, LVS will get clear. But as per the design DFM rules, you should be drawing these things. Okay. So now I will be putting one VR, which is M2 to M3. Okay, M2 to M3 VR I will be putting here and I will hide it. And I will simply align and I will put one here and one I will put here. You will see a red mark on
Sir,
this one will should go. Yeah, tell.
sir, M2 already this track is there, right there.
Where M2 track is there?
Upside.
Here, this side.
There, yes.
It is the same connection
Can
only,
you
na?
switch on only M2, M3, sir?
Okay, M2 and M3. Yeah, tell now.
So already it is there, right? M2 metals from here
Ah,
to another one.
these metals are below metals. You see what will happen if I delete this now? If I delete this one, it will still flag this error, which will
Yeah, all
clean
the
the
metal is there,
LBS.
right? Metal to already it is there, right? Another signal is connecting, right?
I didn't got your point. So metal. So why this is same metal only? To check this one, you
Yeah.
can go to nets and you can mark this one. You can mark and check it. See, same metal only. This is
Then it will be
same
short,
metal.
right? If you route to same, if you route on that metal for the signal.
How it will short?
We are doing metal on that only, right? Routing.
It's the same metal, na? It's the same metal. Why it will get short? Is there any
But it
like
will
see?
short. Yeah, it is shorting to that net, right? What is highlighted, right? That is, it will be short, right? For this signal.
No. Actually, this highlighted things comes from pin to pin. There are pins now. These things you can see, this A, B, C, these are the pin connections. It is highlighting pin to pin. So if you don't draw the metal on top of this one, it will still highlight because the pins, it is not connected properly. It will not get short here. If you see this one, it is not where this is a separate metal. Now, if I highlight this one, see, this is a separate metal. This is a separate metal. But this red one, when it is coming, means it is a connected metal only. Now you got what I tried to say?
Okay.
So when you see, when you are highlighting one metal, suppose when you are highlighting this metal, if it is coming all colors, and it is passing the LVS, means it's the same connection. If I now highlight this one, it will not come. It will is giving a separate color, mean this is a separate net, a separate signal. These two are not same. If I now put one VI at this M2, it will get short. Okay. If I now put a VR on this level by mistake, it will get a short. One second, generate, check against those update. See, if I go here and do extract layout option, extract hierarchical cell views, wait, let me tick them all, libraries, library, and okay. I don't know why it is not coming. This should be a annotation browser should be here. Okay. A annotation browser. See, if you turn on this annotation browser here, if suppose your question is why it is sorting, sir. Okay, there is an via. Let me see this window. Okay, can you see any short options are there? Any coming? Not coming now here. Hello, who was that asking that question?
Yes. Yeah.
So now if I put this guy here, this is a separate net and put this via at this level. Okay, I put one via at this level and I go to connectivity, update, and I do a extract layout. Okay, and press OK. You can see, I think why the short is not coming. I don't know here. It will for sure give a short here. It should give a short here actually at this level. Actually, it should give a shot at this level. I don't know why the shot is not coming. I'm not very might wait 1 second. 1 second, wait. Let it should give actually a short thing should come here. Okay, so 1 second. Let me first highlight it. Why it is not coming here? Okay. Now let me take this net and put a via here. Okay. Might be shot is not showing here. I don't know why. Okay, and let me now extract the layout extractions. Edited cell view, all cell view, and okay. I don't know why. There should be a short kind of option should be there. A short should be there actually. Okay, let me check the short finder is there or not. No, actually, this version doesn't have the short finder. The updated ones have the short finder actually. It will show either short is there or not. Okay, it will show the shots. Yes. No, it is not showing the short thing actually here. It should show the short, but it is not showing. Okay. Okay, not an issue.
DRC will get, right?
No, DRC will not give. LVS gives the shot. DRC will not give the shot. DRC will only just check the what I can say that DRC related issues. Is it passing? It is fabricatable or not? Whether you do a wrong correction and it is passing the DRC, still it will get fabricated, but your chip will not work. Okay. Okay. Last but not least, if you see here, this A connection is still remaining somewhere at this level. It is somewhere remaining at this level. So I think, okay, we need to draw this metal. We didn't draw it properly. We deleted it actually. Okay, let me go and make it 0.26 micrometer. Okay, and one is left. That is our this guy, this pin. We haven't drawn it yet. Okay. Now let me go here and let me put this one again up till this level. Let me put this, but let me put this annotation browser somewhere here. Let me put this annotation browser somewhere here. Okay, and let it will be easy for me to use actually. Okay. Okay, now I have been done this part. Now I will go to the B option, B connection. Now the B connection says that we need to connect this guy from here to this level. Okay, it says, let me probe it and let me make it to orange color. I'm like, So any color you can do. So I will do the metal 3 connection again from here. To do that one, what I can do here is I will be drawing a metal connect track from here by keeping a distance of 0.2 micrometer. 0.2 micrometer minimum I will do it from here. I will try to do it 0.2 micrometer. Simply I will be drawing up till this level. But the problem here will be I cannot pull this M2 up till here. I cannot pull this guy. So, or I cannot do it. So for that one, I need a M4 metal. So M4 to M3. Okay. We can do. So we can just make it 0.26 micrometer, and I will just simply pull this and align this one with this one, and this should be also zero point 0.2 micrometer. Okay, and here I will be putting one via M2 to M3 via I will putting one here. Okay, and let me put one via here, and let me check the distance still I am getting that 0.2 or not. Hopefully we should get a no 0.19, man. It will be a big issue. It can be a big issue now. Okay. What I cannot even route it from here also. It will be difficult for me to route. Or I can use minimum 0.2 is required. I cannot do it at any cost. Doing it at any cost is very difficult to do. M1 I cannot route here. M1 difficult will be there. M1 difficulties. One thing I can do here is okay. One
Sir,
thing we can do here.
if we reduce the metal 3, sir, there on the pin here.
This one we cannot reduce this one. We cannot reduce this one.
This
That's a
one.
default thing. That's a default thing. Okay, let me do think how can we do. Let me do one thing. Okay, sorry. Let me do one thing. Let me turn on all these layers. Already M4 metal is passing from this level. We are just taking this guy M2 to M3, right? Okay, let me sorry. Let me go here and M2 to M3 metal. Okay, so why shall I do it like this? I already have a M4 metal on top of this one. Why I am doing it like this only? I already have M4, right? Already I M4 connecting this guy. So I can just put a M4 to M3 na. Why M2 to M4 only? M4 to M3 only I can put. That will be only good thing. M4 to M3 only I should put actually from this level. Okay. I need a minimum spacing distance of M3 to M3.2 micrometer, but it is not coming actually. Once I can do here is I can increase this one. Okay, I can increase it a little bit and then I can align them like this. I can align them like this. Now this should be fine. Now this should be fine. M3, M2, M4. Okay, now if you see VR2, VR3, okay, and VR4. Okay, now if you see, this should be fine now. It is connecting, it is connecting them individually, it is connecting them properly, and even this is connecting the M3 metal also. What I have done, you got it? What I have done here, I have just taken a M3 to M4, that what I can say, uh, M3 to M4, that via, and I have put it on the top of this one by aligning these contacts with the previous one. That only I have done simply, which will help. Just simply what I have done. If you see here, this was earlier okay available. I have just taken one longer via, and I have just put it here. The spacing is also getting maintained, and this via dislocation is also not there. It is able to connect this thing. We will check the DRC. If we find any DRC, we will check that one once. Okay.
The same
And
via
for
you will provide for 4 rows, right? Same via. Whatever previous via is there, right? For that via only you provided 4 rows, right?
yes, because what happened if we put one via of the same family, and if there is a spacing issue, it will flag a DRC. So what I did, I overlapped each other very perfectly, and even it is connecting this M3 metal also.
Okay.
Is it now clear what I have done?
Yeah.
Okay, now, okay, let me close this annotation browser. I don't want the annotation browser anymore. Okay, let me highlight it from navigator only. It is useful to do it from here only. Remove all, and let me go here and probe this guy. Okay, now what I can check here is I can go to nets connectivity mark, and I can check this one. If you see, it is getting connected properly. But here it should get connected. It is not connected here, but here you can see it is connecting that M4 connection. Okay, it is connecting properly. Okay, what I can do here is unmark all. Okay, now what I can do here is I don't know why it is not highlighting this one. Might be the connectivity. Okay, the connectivity is only not available for this one. That is the reason it is not highlighting properly. Okay. For this one, what I can do here is I can draw a M4 on top of this guy. M4. Let me draw a M4. Okay. And M2 also I will draw it later. 0.26. 0.26 I will draw. And I'll be drawing one metal 2 also as well on top of this one. It will be helpful. Point 0.26. Okay. Connectivity is B, named as B connectivity. Okay. Let me name this as a B also. This is also a M4 only. Okay, now I think if I highlight it, it should go. Now, okay, it's fine. Now what I can do, I have to draw a M4 metal again here because this is not connecting this one. So what I will do, I will draw M3 is already there. I will just draw a M4 metal on top of this guy. Okay. I will simply draw a M4 metal, and I will be just making it as 0.26. Okay, and I will show you how to do that one. I will go here and I will make it as M4 to M3 via because M3 is there and M4 is there. I will just do it like this and I will place it simply here. See, M3 to M4 connection has been done. M2 is not getting connected here now. Okay. Now this M4 is jumping this M2 and it will come up till this level. And here what we will do, we will use stack via. Stack via means if we start with M2 and end with M4 means M2 will be there, a M3 will be there, a M4 will be there. This kind of via will be there. Then we can make it high, then we can make it larger values, and we can just implement this one at this level simply we can pull this one at this level and we can just enlarge this one simply. Okay, we can enlarge it up till here, and we can draw one metal 2 also on top of this one. We can draw a metal 2 as well, also on top of this one. And I can just simply make it 0.26 simply. Okay, it is just connecting this whole thing. If you now select this one, you will able to see the whole thing is connecting at this level properly. Only this guy is left. We will connect these pins later. If you see, this is connecting here properly with every measurement actually passing. If we put these pins here, if it will go actually. This error will actually also go. If you put these pins here actually, if let me do one thing, let me do the pin and show you guys that it will be easy for you to understand. Sorry, this pin, suppose I am taking this A pin and I am going in the top here somewhere and I am putting this pin at this level. Okay, and let me select the whole thing and one second. Okay, and let me make query common and let me get the M2 pin and press OK. It should go now. If you see, it will go. See, A, this yellow marker has gone. For the B to remove the yellow marker, you have to do one thing. You have to go here. Excuse me. You have to take this guy, B option, B connection, sorry, B pin. You have to come here and you have to place it somewhere this level. Okay. Somewhere this level you have to place it. You have just selected whole thing, just select it, query, make common. If you don't press common, only single will be get changed. If you make common, then whole selected part will get changed. Okay, and make it to M2 pin and press OK. If you now do, you will able to see the yellow marker on the pin should also go now. Okay, why it is not going here? Okay, let me open the annotation browser again and let me check it once. Why it is not highlighting? Hmm. Let me extract this one again. Extract layout. Okay, okay. Open net on B between path A on metal 2. Path A, where is path A here? When metal 2 actually it is highlighting. Let me draw some metal 2s over this one. I think then it should go. Metal point to 6 and then they should go now. Hopefully they should go. Now let me draw one metal 2 on top of this one again. And let me 0.26 and it should go now. Oh, still not going. Might be some extraction error is there, not an issue. This is there and this connection is there. Let me check this net connection. It is connecting this or not actually. Actually, it should connect actually. Sorry, the color is not okay. Unmarked. Okay, let me unprobe all and let me check this one. Okay. P connection, connectivity, nets, and mark. Okay. Okay, it is connecting properly. It is connecting. Not an issue for there. It is connecting properly. There is not an issue. Don't need to worry for that one. Okay. Okay. So up till here it is done. We have to now kind of C input. Let me remove this one. Unmark all. We have to kind of C input, which is these two guys. These two brothers actually. For this one also, what we can do here is, if you see this guy, it is assuming to be come from this level. Okay, for that one, what I will do here is I will just simply turn on the three metals. Okay, for this one, I will be drawing one metal 3 again. I will draw a metal 3 again from this level. Okay, and I will pull it up till this level. Okay, this level I will pull it and I will make it to 0.26. I will make it to 0.26 and I will align it with here. Spacing will not be a major issue here. And then, sorry, and then I can make it up till here. Okay, okay, okay. Okay, then I can put M2 to M. So here we will putting M2 to M3 via first. M3 underscore M2 via here. Here will be M2 underscore M3 via. Okay, and here the via will be M4 to M3 via. Okay. What I will do here is M4 to M3 via we will put here. Okay. We'll put the via here as M2 to M3 via, and we will be drawing a layer again here on top of this one. Okay.
Sir,
Yeah, tell.
sir, which metals should be horizontals and which metals should be vertical, sir?
Uh, even metals should be horizontal, odd metal should be vertical. Hello.
Yes, sir.
Even metal should be horizontal and odd metal should be vertical. And here the M2 I will draw on top of this one again. The M2 I will draw up till this level. Okay. And I will make it as 0.26 again. Now, if I see this one, it is highlighting this guy. Okay. I will be taking this guy from here. I will take this guy. Okay. I will take this one, and I will stretch back C in this guy. Okay. And I will try to put it in the top. I will try to put it in the top actually here. I will try to put this one in the top somewhere here. And I will be making this guy and this also as a metal 2 pin only. Metal 2 pin only. Okay. See, if I now go and check, it should come actually. It should come actually this one. Okay, it is highlighting at this level. Actually, it is see telling be an instance 0A path on metal 4. Actually, due to if the connectivity is fine, then still it's not an issue actually. Actually, might be the reason that M4 is there. That is the reason actually it is highlighting. So not an issue actually. So if you go and check with the to final check, you have to go to nets and mark this one. Don't rely on this navigator and annotation browser. Okay, it is just to give you the information for the connectivity. To final check the connectivity, you have to go to connectivity, nets, mark, and then simply check this one whether it is connecting this or not. It says that it is connecting properly these things, then it is fine. If you rely on this one, you will for sure might get a LBS issue. Again, for the C out is outside, not need to worry for this one now. Okay, now we have to connect these guys also. Okay. So these two should be also get connected. Okay. This one from here, and what I can say, this one from here also need to be connected. To connect them, we had a connection here. We had so for that one, what I have to do is I have to check this net connection. So let me first probe it out. First probe it out this one and go to connectivity, mark, and let me pull it here. Okay. Let me put it somewhere here. Okay. What it says that the connections should be up till this level only. Okay. I have only the connection up till this level, except I don't have any area to connect it. And for this one also, it is up till this only. So for this one, I can pull a bit metal 2 and I can use a metal 3 to short it here. But how we will connect it here? Yeah, we can do it. We can do it. We can do it. We can do it. For this one, what I will do here is I will simply pull the metal 3 a little bit outside and pull the metal 3 outside here, and I will make it to 0.26 here. Okay. And same metal 3 I will copy and I will paste this one here also. Okay. And then what I will be doing, I will be taking this M3 outside here by maintaining a distance of 0.2 micrometer minimum. Okay, 0.2 micrometer minimum I need. This is the DRC distance between the parallel lines. Okay. And then what I will do here is I will simply pull these guys back up till this level and I will align them properly. I will just pull them up till here and I will make them aligned properly up till this level. Okay, and then option I will make M4 to M3 to M4 again, and I will try to hmm, the problem is here actually. A big problem will come. I think for here we need to rotate this via. Rotation can only fix this one. See, rotation everywhere is not allowed actually, but the constraint here is actually very difficult to do. That's the reason only I rotated. So please don't consider to rotate it. It's not advisable every time. So only do whenever it is required. Otherwise, please don't do this rotation. Then what I can do here is I can simply go here. I can pull this metal again from here. Okay, and I can come up till this level. Okay, M4 is already there. I cannot draw a M4 again at this level. All three, if you see, all three tracks are filled with M4. Only the way to pull the M4 here is either on device, either on this track lines, either on this track line. The track line means I have to say this part. Okay, here I can draw a M4 here. Simply I can draw a M4 here. I can simply draw a M4 at this level. Okay, at this level, I can simply draw a M4 and I will make it as 0.26 micrometer and I will make a M4 to M3 via here. There is no M3, no M3. I'll make a M3 to M4 via here. And here I will be taking one again M3 metal from this level. From this level again, I will be taking one M3 metal. I will be trying aligning this replication of this one only. I will try. Okay. And I will put it somewhere here. Okay. And I will make it as 0.26 micrometer. Okay. Or I can do here is I can just try this one up till this level and leave it. Just simply leave it. And then I will just pull this one back. I will make it as again here, this guy, M4 to M3 metal again. M4 to M3 connection should be here. And here it will be M2 to M3. M3 to M2, simply. You will see the whole thing will get connected now. Now just draw a metal 2 on top of this one. It should go fine now. It will go fine now. M.26. Now it should go fine properly. A kind of a bended connection came, but still it's fine. So the output, you can see this has gone actually. Okay. Now if I remove all and de-highlight this unmarked connectivity, you will see now the net 24 is required to be connected. So net 24 connection is very easy to do. We can just pull the metal 3 from here. We can simply pull a metal 3 from here and we can just draw it up till this level by making it 0.26 micrometer. And simply I will be taking this one and I will be aligning this with to this level and M2 to M3. That's fine. Again, I will be doing this here and I will be putting one via also here also. And I will be drawing one metal 2 also here. Okay, I think this one, this one. Metal 2 only I will draw from here. I will make it as 0.26. Okay, it is not aligned, right? This is not aligned up till this level. What I can do here is I can just align them up till here. Okay. 1 second. They should come. They should go. Okay. I think this also has been done. Net 24. Net 25. If I go, it also says that this kind of connection only required for that one. What I will do, I will just turn on these metals and I will try finding. Okay, so for M3, what I can do here is I cannot just directly jump a connection from here. I will be just putting one metal here somewhere at this level. Okay. Excuse me. I will simply jump a metal from this level and I will make a M3 to M2 connection first here. I will make a connection like this one here. And this, sorry, where is this one? This one, right? Here I have done properly. So what I can do here is if I pull this M3 here, it will get short. So for that one, what I need to do here is either I need to bring this one up till this level. Again, this short will come. For this one, what I need to do here is I need to check to M1, what the M1 can. So M1 is there, a lot M1 is there. So what I can do here is okay. I can simply pull this M3 up till this level. I can I will take this M4 from here. I will copy this M4 from here and I will put it at this level. I'm just copying it, nothing else. I have just copied it. Okay. And I will pull this one back. Pull this one back and I again. Hello guys, can you able to hear me? Or any audio issue is there? Hello?
Yes, sir. Audible, sir.
Okay. Again, I will do a M4 to M3 I will take. M4 to M3 I will take and I will put one here. M4 to M3 I will take and I will put one here. Okay. M4 to M3 I will put and I will go here. And here again I will take a M3 metal. Simply I will take a M3 metal here. To 6 and I will simply make it aligned up till this level. Okay, and I will pull this one back. No extra hanging metal should be there. Okay, again I will put a M4 to M3 metal somewhere here. This should be okay, and this should be M2 to M3. This should be M2 to M3 actually. Okay, this should be actually M2 to M3 here. Okay, if I now see this one, you will able to see this net 25 yellow marker has also gone. Okay, you can just de-highlight it, remove all. You can go to net 26. Net 26 is already connecting each other. Just draw a M2 metal on top of this one. It will already get connected. It is already connecting each other. You just need to draw one M2 metal and 0.26 make it, and it should go now. See 0.26, net 26 also done. Okay, now net 27 comes. So from net 27, what we need to do here is just simply take one M3 Okay, sorry, net 27. Let me highlight it again. Okay, this metal, this below metal, let me turn off this M4. You'll able to see this M4 should be connected with this M2. See M2 to M2. Okay, just simply take this one, come back here, align it somewhere this level. Okay, excuse me. And sorry, then this one I will take and I will align it somewhere till this level. And I will be drawing one M2 metal on top of this one. Simply I will draw M2 metal on top of this one. And I will be just making it 0.26 only. 0.26 here. And I will put a M2 to M3 via here. Simply put a M2 to M3 via here. Okay. What is the issue coming here? Is B. Okay. It says it's next 27 and I've copied that na. That is the reason it is coming here as a B connection. I don't need as a B. I net 27 and okay. And then now I can put one via here. It should be okay now. Yeah, okay now. Now this okay. Hmm. A issue is there. Why I can see this issue? This issue is this guy. Wait, let me pull this one back first. Okay. Then what I can do here is I can just simply stretch it back, or I can copy this one up till this level. Okay. Or let me do one thing. Now I can pull it somewhere up till here. Okay. And let me first make a distance of 0.2 micrometer from this level. Okay. And then I will copy it. And let me delete this one first. And sorry, and I will just pull it up till this level. 0.2 micrometer up till this level, and I will just simply pull it up till okay, and I will just stretch this one up till okay. Let me delete it. I don't need this one. I will just simply take another one and I will align it like this. Okay, now this should be go fine. Okay, and now here again draw a M2 metal and you can just simply align this one with why I removed, because there is already a M3 VI is there. So that is the reason I removed it. Nothing else. 0.26. Okay, and we need to put a VI also here. That should be go fine now for this one. Okay, it is done. This is done. If you see here, net 27 also done, and we can remove probe and remove all. Net 28 is left. These two things should be connected. Okay, these two things should be connected. Means this net connection. So is it connecting from some other part or what? Is it connecting from some net and unmark? Let me unmark it and let me mark again. Okay, I think a M4 is there, if I'm not wrong. M4 is there. Unmark all. So for here, what we can do this is M2 connection is there. So net 28, we have to connect these two guys. To connect them, we can do either. Okay, I cannot pull a M3 directly here. metal 2 is already there. For this one here also I cannot pull one. If I pull one of the metal, I will be stuck with this between these metals because M3s are already available here. So for that one, what I need to do here is let me check the metal one tracks. So metal ones are already there, na? What I can do here is, okay, I can just pull it.
Sir, your audio is not.
Hello?
Yes, sir.
Hello?
Yes, sir. Yes, sir.
Okay.
No, it's all.
Okay. I think sometimes the audio goes, so sorry for that one. And again, I will be taking one M3 track up till this level. And I will be making it as 0.26 micrometer. And I will be aligning this one with this one again. And I will be putting M2 to M3 via again here. One via here and one via, again I have to rotate this one. So two rotation happened in this one. I could have planned it in some other way. Then rotation would haven't come. So no issue. Okay, so up till here it is done. So the S output. So output will be output. VSS, VDD should be connected. C out should be there actually. If I go and check now, the C out should be there. Let me do the C out once. Let me put the C out terminal somewhere here and let me change this one to common and M2 pin here and okay. It should go now. C out gone. C in, what about C in? C in also done. I think some that M4 thing is there. So that a big issue. And output B connection. So for the B connection also, wait 1 second. Remove all. Okay, for the B connection, I think for the B connection, it is highlighting at this level where the M4 is there, that only highlighting. Okay. Okay. The S terminal should be connected. S should be connected at this level. Okay, it should be connected at this level. Excuse me. S should be connected at this level, common, and make it as M2 pin. M2 pin here. Then remaining is VDD and VSS. VSS should be at this level. We have to create a power planning for this one. Then only this VSS and VDD we can connect. Let me put the VDD in the top only. Let me put the VDD in the tops. Okay, for now, what happens here? Let me just take this PR boundary. Let me take this PR boundary somewhere here. Where is this PR boundary here? Why I cannot highlight this PR boundary? I think that PR boundary got deleted or what? Okay, let me hold it from here only. And then I can pull it somewhere here and again. Excuse me. Okay, the PR boundary is now okay. I can just simply make it a edit advance move origin. Just make it to move origin. Okay. If you see here, you will able to see unmark all. And let me unmark it all. Okay. If you see here, all the connections have been done for this one. Okay, only the power planning is left out. So we can do the power planning later. So the power planning is nothing else. See, the VDD is there. Suppose a VDD connection, wait 1 second, a VDD connection at this level is there. Okay, one VDD is there, one VSS is there. Okay, and one VDD, one VSS is there. Then again one VDD, one VSS, one VDD again. Okay, now my point is how one VDD, VSS, VDD, VSS, VDD. Okay, so two VSS. So to connect these two VSS, we need a track. Okay, I'm just making it this as a like this. Okay, and for to connect these all VDDs, we need a track like this, which will be I'm correct. I'm symboling VDD as 3 lines and VSS as 2 lines. Okay, so all the VDDs will get connected. Okay, excuse me. So I'm making, suppose this is a one VDD here or one VDD here. Okay, and for the VSS, one VSS is here and one VSS is here. Okay, so we have to connect these VDDs accordingly. We have to connect these VSS accordingly. So you can use a metal 5 pin on top of this one to connect them. Okay, so this is how we can do the power planning as well. I have done to show you guys how to do the VDD and VSS power planning. So I am not doing this one now. So it will take some more half an hour to do it actually, because some DRC things will come to connect them. So this is how you can route for a full adder. So this is how the what I can say, floor plan routing of a full adder, routing of a full adder looks like. You can modify the placement, device placement also, and you can do it accordingly. So that's not an issue. You can do it accordingly also. You can change as per requirement, but you have to maintain the signal flow every time. You cannot change it. Okay. So is there now question you can ask me? Hello? Hello? Hello?
Sir,
Yeah. Who's this? Tell.
I'm Pratyusha, sir. Sir, instead of rotating the via, we can use the single column, sir, for via.
No. Single VI is not allowed to do as per the DFM rules.
Okay, sir.
Any other guys, please tell. Hello. 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 Saima, Lohita, Arshad, Pratusha, Srikant, Sandhya, any queries you can ask me?
No, sir, not right now.
Yeah, Saima, tell. No queries?
No, sir, not yet.
Okay.
Thank you.
Yeah, thank you. Arshad, Lohita, Srikant, Sandhya, you guys can ask any questions.
Sir, doubt, sir.
Yeah, ask.
Hello. So,
Yeah, you can ask.
suppose if I route the signal on the metal 2 layer, one signal. So again, we can route the same so another signal also we can route, sir, on that one.
So the signal should be same, na? If there's so see,
Oh, signal should
suppose
be
one
same.
suppose
Signal should be
no
same.
no
Otherwise, we can't route,
no
right?
no, suppose one M2 track is passing, okay, you
Yeah,
have done one routing for the M2 track. Now suppose assume M2 is renamed as a signal A, okay, and there is a signal B also which will also cross that M2. So to cross that M2 you cannot route with a M2 only. M2 will get shorted. So you have to use M3 or M1 or any other metal other than M2. Then only you can pass it. It
Okay.
can be
Same
any
thing.
other signal. No, other signal can also pass of that. Suppose signal A is there, signal B is there. Signal A and signal B can cross each other at a junction point. Okay, like a plus symbol. Suppose imagine it. Okay, plus symbol is creating. So
Can you draw, sir, one second? Can you draw it? Something.
okay. Suppose this is a M2 metal. Okay, suppose this is a M2 metal. Okay,
Yeah.
suppose this is a signal A. I'm reading it as signal A. Okay, now you have other two signals. Okay, suppose this is a signal B. Okay, this is a signal B, and suppose this is a. Oh, sorry, let me color it. Okay, now sorry, this is suppose a signal B. This is a signal B. Okay. Now let me draw a signal C also. Okay, it is passing.
Yeah.
Signal C. If you are drawing this B or C with the same metal, the red one, then it will get short. But if you are drawing this with a different metal like M1, M3, M4, any other metal, then it will not get short at this level unless you put a via there.
Okay. See, sir, actually, A net is there. So if I run the net on the B net on the A net, we can route, right?
Can you repeat again?
So B net is there actually on the A net. We can route,
Hmm.
right?
You can route
Different
unless,
net.
but different metal should be there, but not same metal. If you use the same metal, you have to either maintain the spacing between them. It cannot overlap each other. If it overlap of same metal of a different signal, it will get short.
Can you repeat, sir? Not getting.
I am telling if the signals are different, but you are routing with the same metal and those metals are overlapping each other, it will for sure give a short.
Okay.
You need a different metal to route there. To now you want to connect both the signals, you have to put a via there.
Okay.
Mhm.
Okay, see that. Yeah.
So, sir, I have a quick question. Let's say I've seen like you were jumping from upper metal to the lower metal. So that how
Mhm.
you connected. So um, you started with a metal one, connect all the connections done, then going further up along the way to avoid the shorting of the other metals. So you went all the
Mhm.
way up from the lower metal to the upper metals, right?
Yes.
And then some points you came down from 3 to 4 or like 4 to 3, something like that.
Yes, that is actually required because why I did actually it as per the situation. Suppose a M2 metal is there, I have to connect a other M2 metal. Okay, but I directly cannot draw a M3 because a M3 in the middle is waiting or other signal is waiting. So on
Mhm.
that case, you have to use a M3 and then jump using a M4 metal. Then
Mhm.
because there is a M3 in between that one, because two M2s are there and one M3 is there. Okay, suppose the test case is like this. The test case is somewhere like this. Okay, two M2 metals are here. Okay, two M2 metals are here. I had to connect these two. Okay, this is signal A, this is also signal A. Okay, But the problem here is occurring. I can draw this one with a M3 directly. Okay, I can draw this one with the M3 directly here. But the problem here is other net is passing from this area, a M2 net, which is a signal B actually. If I consider signal B, this one, and some connection is there with a M3 connection here. A M3 connection has already been here. Okay, already I have a M3 connection here passing to going to some other net from this one. Okay, it is going to some other net actually. Suppose it is going to some other net. Don't consider this net, other net. Now, if I want to draw a M3 on this one, it will get overlap and get shorted. I don't have a space in left or right. Okay, I don't have any space. I cannot draw. So what we have to do in that case here is we can draw a M4 metal here. I will draw only a bit of space is the left side. I will draw M4 metal here. Then I will be drawing one M3 again here. And I will be drawing this M2 at this level. It will get connected. Now got, Saima?
Yes, sir. Thank you.
Like this is only we have to do because the shots will be there. Now how you will draw them?
Sure. So almost looks like a maze. So
Yes, this is the only it's like a puzzle. It's very, if you want to get friendly with the layout, you will able to enjoy the layout actually. You will able to enjoy the layout. If you want to get familiar with the layout, you will able to enjoy it a lot.
that's right.
This is how you can do the layouts. Any questions from guys? Yeah, Lohita has a doubt. So, like, Lohita, can you turn your mic and ask the question? You can ask here only that issue. I will help you out. Hello, Lohita.
Yeah, Subhash, can I connect with you at 3 o'clock?
Okay.
Yeah.
Arshad, can you are you able to free at that 3 o'clock? We'll able to sort it out for you also.
3 o'clock, sir.
Yeah, 3 o'clock, Arshad.
Okay, sir.
Please plan your schedule accordingly so we can connect around 3 o'clock. Okay.
Okay, sir.
Okay, everyone. Then we can end the session today, and we will meet again in the next. So before going forward, please try to practice this. See, if you